Hello. In addition to my previous videos on ordinary differential equations in which we solve both second and first order linear and non-linear equations, I want to do something different this time, and what I actually want to go through and explain is uh, the principle, if you like, that 0.9 recurring is equal to 1. So how do we know that 0.9999 forever and ever and ever, normally written like so, 0.9 recurring, how do we know that that is equal to 1? Well, there's a simple proof of this. In fact, there are 4 proofs of this. And what you do is you put x equal to 0.999 recurring. So how does that help us? Well, that by itself doesn't help us very much. Um, but what you can do is you can multiply both sides by 10. So you get 10x is equal to 10 times 0.999 recurring. And if you work that out, you get 10x is equal to, well, what's 10 times 0.999 recurring? Well, what happens is if you multiply 0.999 recurring by 10, then the decimal point moves up 1 place so that you get 9.999 recurring. So let's just erase this line so that we can see what we're doing. This is equation 1 and this is equation 2. Okay, so subtracting 1, that's equation 1, from equation 2, we have well, you've got 10x minus x, so you're subtracting x from 10x, 10x minus x, and of course you have to do the same on the other side, so it's 9.999 recurring minus 0.999 recurring. So 10x minus x is 9x. And what's 9.999 recurring minus 0.999 recurring? Well, we're assuming that there are an equal and infinite number of 9s after the decimal point in both cases. So 9.999 recurring minus 0.999 recurring is just 9. Okay? So you can see that if you divide both sides by 9, you get x is equal to 9 divided by 9, which is 1. And this implies that since x is 0.999 recurring, then that is equal to 1. So that is the proof that 0.999 recurring is actually equal to 1. And what we say is that basically this is a convergent sequence, and mathematically the correct way of explaining this or describing this is to say that 1 is the limit of 0.999 recurring. And we can even go further with other fractions.
One thing,
Yes.
I noticed you put 0.999 recurring dot.
Oh, that's just me putting that's just habit, putting the pen on the board. Yeah, I know I shouldn't do that.
What would you put?
Well, you shouldn't put anything. It probably should be a comma.
I meant 0.9 with the dot on the top is sufficient.
Yes, it is, but
It's
it
good
might not be obvious to everybody.
yes.
There are probably GCSE students who don't necessarily, if they see 0.9 with a dot on top, they might just take that to be 0.9.
Mm.
You've got to make it obvious that you're talking about an infinitely repeating decimal.
Hence
So
you put 0.999 dot.
So what about if we have x equals 0.666 recurring? Oh, that's an interesting number, isn't it? Yeah. So maybe the devil is in the detail. Okay, what's that as a fraction? Well, let's see if we can work something out. Let's try multiplying by 10 again. So we get 10x equals 6.666. So the decimal point moves up 1, and you just add on another 6, you know, just for consistency. So if we subtract, and we'll call this equation 1 and this equation 2 again. So subtract equation 1 from equation 2, we get 9x is equal, well, if you subtract 0.666 recurring from 6.666 recurring, there should be a little dot above that, we get 6. Okay? So dividing both sides by 9, we have x equals 6 over 9, and that can be cancelled down to give, well, it cancels by 3, doesn't it? So divide by 3 to get 2, divide that by 3 to get 3 2/3. If you type in 2 divided by 3 on your calculator, you will get 0.666 recurring. This implies that 0.666 recurring is equal to 2/3. And we can extrapolate that to more complicated decimals. So we'll try an example and see if I'm up to scratch for these more involved decimals. So let's suppose we have a number x equals 0.523523523, and that repeats. I'm not quite sure actually how to. Would you put a dot above the 5, the 2, and the 3?
Well, actually, yeah, the 5 and the 3.
Right. What, the
put
5 and the 3?
Yeah,
Like that? I can't remember.
Yeah, you put it at the beginning and the end of the sequence.
Right, okay, but you don't with the 2. No, okay. So, how are we going to, do we multiply by 10 or 100 or 1,000? You've got to look at this and see how many decimals it takes before you get a repetition of this number. So you can see that after the third decimal place, you then get a repetition of this number, and then after the 6th decimal place you get a repetition of the number again, and so on. So we're looking at multiplying x by 1,000. So if we multiply by 1,000, we get 523.523, 523, 523, like that. So what happens when we subtract x from 1,000? So subtracting, we'll call this equation 1 again and this equation 2. So subtracting equation 1 from 2, we obtain, well, 1,000x minus x is 999x, and 523.523 recurring minus 0.523 recurring is just equal to 523. So x is equal to 523 over 999. And I'm just wondering if that can be cancelled down anymore. So I'm going to get my trusty calculator because I want to prove that if I can find my calculator, which strangely enough, here it is. So we have got, well, first of all, we'll type in, let me just get this in front of the camera, 523 divided by 999 is equal to 523 over 999. So that cannot be cancelled down anymore because the calculator says so. And what it's got there is 0.523, but actually we need to put it into engineering or scientific form. And of course what we get is 523, 523, 523. It's put it into scientific form. It's multiplied that by 10 to the minus 9. But that should indicate where the decimal point goes. So the implication is that 0.523, 523, we'll just truncate it there, is equal to 523 over 999. And you can do this with any repeating fraction. So
Can I put you on?
yeah, give me one. Yeah, give me a question. Yes.
Right. So it's 0.243,
Right.
and the recurring goes over the 4 and the 3.
X equals 0. What was that?
243.
243.
And the dots go over the 4 and the 3.
Right. Okay. So in actual fact, it's 4343.
Yeah.
Sort of like that.
That's it. Yeah, that's it.
Okay. Right. Well, how are we going to solve this? Now, just thinking about it, the repeating numbers are 434343. We could try multiplying by 10 or 100. Let's try multiplying by 100 because what we want to get the 2 over here, if we can, 2 and then something such that the 4 3s line up. That's the way I'm thinking of it. So you see, if we multiply by 10x, and I don't think this will work, we would get 2.43434344. So you can see that the 3s and the 4s and the 4s and the 3s do not line up. So what we need to do is, can you repeat that number to me again, Chris? X equals 0.2434343.
Yeah.
So what we need to do is to multiply by 100, and that will therefore aid in lining up all the 4 3s in the new number. So if we multiply by 100, we get 2, 4. In fact, I don't think that doesn't work. So let's try 1,000. Let's try 1,000. 2, 4, 3. Just a minute. You picked the right one here, Chris.
And then
Just a moment. Let's try 10,000. Let's try 10,000. I'm glad you're amused at my discomfiture, Chris. Let's try 10,000. So we've got 2, 4, 3, 4. Now that's, I think, my goodness me, you've got me here, Chris. Just a moment. It's got to be multiplied by 10, 100, 1,000, or 10,000. Let me think. It might even be 100,000. 2, 4, 3, 4. Point 3, 4, 3. That's not very helpful, is it? Oh, wait a minute. We've got a 3 there. The next to 2 decimal places, we've got a 4. So I think we're on the right tracks. So there we've got a 4 in the second decimal place. There we've got a 4 in the second decimal place. So if we subtract x from 10,000, we get 9,999x. And if we subtract that from that, we get 2,434 points. Well, 2 from 3 is 1, and everything else should just cancel out. So in actual fact, if we move the decimal point now 1 place to the right, we have to do the same on this side. So that's 99,990x is equals 24341. Is that right, Chris?
ooh, I don't know. Yeah.
So x is equals 2434 divided by 99,990. Let us try on our trusty calculator what we get. So 2434 divided by 99,990.
What do you get?
And we get 0.02434. So I'm a factor of 10 out, aren't I?
No. Oh, right. No.
Look, that's what have I done it right?
Oh. What's happened there?
Oh, wait a minute.
Oh, done. 99824.
What have I done wrong?
2434.243. You've taken away 243 from no, wait a minute, 24.
Yeah, 2434.
That's right. It's right. It's all right.
You take 2 from 3 is 1, and then the 4 from the 4 is 0. The 3
Oh,
from 3 is
it should be
0.
24341.
That's what.
That should be 24.
Oh, of
1.
course, yes. Chris saves the day. Right, let's try it again. I do make these mistakes. I keep on telling anyone who watches these videos, I make the most abysmal mistakes, usually with minus signs, but often with things like that as well. So if we now work it out, that cancels down to 241 over 990.
Does it?
Yeah. So let's see what it is as a decimal. And it's 0.243. Recurring.
Right. So now, Steve.
Yeah.
Try multiplying just by 100.
I am going to try and do that, yes. Did you see where my top went? I
Yeah, it went
dropped it
over
on the
here.
floor. Oh, it's by your foot, your right foot.
Yeah.
Just
Just try and multiply by 100 and
okay.
subtracting 100 extra from x.
Yeah. That door's banged twice, hasn't it? So we've got x equals 0.2434343. Right. So if we multiply it by 100,
Yeah.
x, then we've got 24.34343. Oh, now that's interesting. That 2 corresponds to 3. Yes, it should work. So we've got 9. If we subtract, we call this equation 1 and this equation 2. It's nearly overlapping with our working here. So if we say subtract 1 from 2, or 2 from 2 minus 1, we get 99x is equal to 24.1. Right. So then multiply by 10 to obtain 990x equals 241, and x is equal to 241 divided by 990. Exactly what we have there.
So
The
you,
implication being, and you've got to write it like this, that 0.2434343 recurring is equal to 241 over 99. My 9s look more like at signs, don't they, or A's. 990.
so one final method is
Yeah,
you multiply by 10 and you multiply by 1,000.
yeah. You do actually. Really, that would have been the best thing to do. And we'll just give that a go.
So the reason you multiply by 10 because that's the decimal that's not recurring,
Yeah,
and it gets that out as a whole number.
yeah,
And then you multiply it by 1,000 because you want to get that. You want to get that. You want to get the 4 3 aligning again.
yeah. So if we do that,
Yep.
I should have perhaps written this in red. I hope it's showing up on the. It is showing up on the video. So that's equation 1. If we multiply by 1,000, we get 243.4343. So that's equation 2.
And then you multiply by 10.
Well, that would be multiplied by 10,000, but it would shift that up to the wrong place.
Just multiply by x by 10. 10x. Write down 10x
Right.
underneath. Write down 10x underneath.
10x
Equals
2.4343 recurring.
So subtract 10x from 1,000x.
10x from 1,000x, right? So that's. Tell me what it is, Chris.
What's 1,000x take away 10x?
Yeah.
What is 1,000 take away 10?
Well, 1,000 take away 1 is 999.
1,000 take away 10.
I can't think. I can't see it's going. You tell me.
990.
You're supposed to be the student.
900.
You're supposed to tell me when I don't know, but I'm pretending I know, and I'm asking you because you're the one who's learning. And
990.
990.
X.
990.
990.
Yeah. 990 x equals.
Well, it's just 243 minus 2 is 241.
241. You're brilliant, Chris.
Was only
You're ahead of me.
This, isn't it? Over 990.
990.
That's where it all
So I hope for those people who are going to view this video, because I'm actually going to put it online, that you have learnt something, and even though you're watching a very, very blundering mathematician, that you will have enjoyed this and learnt something from what you've been watching, and that you will come back for more, and possibly watch some of my previous videos on ordinary differential equations. And I will be putting more videos up. I'm planning on doing a more varied range of videos, including things like this, but a wider variety of all sorts of things. Hopefully with my friend and student here, who is really a mathematics teacher, to keep me in line. So hopefully we'll be able to do a few more of these videos. So I'll stop the video there, but see you later.